In this video, I'll go over some basic ideas behind the Arduino Uno microcontroller. As you can see on the board, you have the power jack. The adapter will be connected to this power jack. You also have the USB port as well that you can basically connect it to your computer, and when you code, write your program through this USB port, you can upload it onto the board. The Arduino microcontroller board, it has a number of digital pins. The digital pins are set on top of the board from pin 0 all the way to pin 13. The voltage on these pins can either be 5 volts or 0 volts. So these are digital, either on or off, 5 volts or 0 volts. And those pins can be used either as an output or input to the board. You also have analog pins, pins 0 through 5. These are only used as input on the board, basically. The analog signal, basically the voltage can vary. It doesn't have to be either max or minimum, 0. You can vary the voltage on these analog pins, and basically the range of that variation is between 0 and 1023. You also have this, going back to digital pins, you have pulse width modulation, PWM pins. Some of the digital pins are designated as PWM pins. These pins, basically they are digital pins, but they can simulate or behave like analog pins. So you can actually vary voltage on them. And the range of the variation is between 0 and 255. You got to keep that in mind, basically. Sure. All right, let's start our first program. Here, we are basically going to turn an LED light emitting diode on and off. First, we'll assemble the circuit. This white piece that you see here is called breadboard. On the breadboard, on top, all these pins, all these holes that you see here, they're all connected. The holes in a row, they're all connected. Same thing with the holes on this row, they're all connected. Now, in the middle though, these pins are connected vertically. So all these pins are connected, and then all these other pins are connected. Similarly, if you consider this column, so the pins are kind of connected. They are assumed to be the same column-wise in the middle. And then at the bottom again, row-wise, the pins are all connected, meaning that they are at the same potential, at the same level, basically. So first, what I do, I build the circuit. To build the circuit, I need, I'm going to use pin 13 right there. That's a digital pin, and bring it all the way onto the board, the breadboard, connect it to resistance. That's the pin of the resistance. So this point right here, that's a point of connection. As I said, all these points, they're all the same. So they're connected to resistance, and then the other side of resistance is connected to diode. This is light emitting diode. It goes through the diode. So this is basically the circuit, starting from pin 13, going through resistor, going through the diode, coming out, and then continuing right here on this second leg of the diode. It goes back to the microcontroller board and to the ground. So we have a full circuit here, closed circuit here, right? Basically, the current will flow through this pin 13, it goes through the resistance. The resistance is there just to kind of limit the amount of current that goes into the diode. Otherwise, if the voltage and current is just too much, it may burn the diode. So it's just a limiting resistor in there. And it lights up the diode and then back to the ground, basically. You can go to this site, fritzing.org site, and in there you can actually find breadboard and Arduino Uno board, and you can create diagrams such as this one yourself. Mine isn't that great, the lines are not straight, but again, going to this site, you can easily, this is for free, you can actually create your designs. Now, once you build your circuit, then you have to go to the sketch, the IDE for Arduino, which you have to download, and then write your code. When you open a project in Sketch in Arduino IDE, you will have two functions already placed in there for you. One function is called setup, and the other one is called loop. Inside the setup function, which executes only once, so this function runs only once, and inside of it you do the initialization, starting initialization. And then once the setup is executed and it's complete, then the code inside the loop is continually executed. So the code that you see inside the loop will be executed, then it goes to the top of the loop, executes the same code, and repeats it over and over again. Now let's look at the code. It's pretty simple. You declare a variable, an integer variable, we call it pin 13, and set it equal to 13. The number 13 basically indicates we are dealing with pin 13 right here. Right? So that's a declaration of variable. Then inside the setup, we have to designate the mode of the pin. In this case, we'll say pin mode, that's the command in Arduino. Pin 13, that's our pin. We are going to use it as an output. Right? So we're going to basically the energy or the current is going to flow out of it. It's an output. Right? So that's the initialization that's done, and then once this line of code is executed, it jumps to the loop and executes the loop. What's the first thing in the loop? Digital write, another command. Digital write pin 13 high. So this is a function which is called digital write. It has two parameters. The first parameter is our pin 13, and then the second parameter is the value of it. And in this case, it's the constant uppercase high that we have to place in there. So I'm basically saying, okay, put the voltage on this pin, which is going to be output to 5, right? And then there's a delay of 2 seconds for that, and then after 2 seconds, I'm going to write on that same pin. I'm going to lower the voltage to 0. So pin 13, set it to low, wait for 5 seconds, and then goes back up. Sets the pin to high for 2 seconds, sets it to low for 5 seconds, sets it to high for 2 seconds, low for 5 seconds, and this continues indefinitely until I turn off the machine, basically. Okay, in this example we'll work with analog pins. In order to use the analog pins, I'm going to also use this potentiometer device. It has 3 pins, the potentiometer. The far left and far right pins go into the voltage and the ground pins on the board. So this pin is connected to 5-volt pin, and then the rightmost pin connected to ground. Doesn't matter, you can switch them. But it's important that the middle pin go to one of the analog pins. In this case, it's gone to analog A0. Now, by this potentiometer basically is a resistor, but you can change the value of the resistance of it. And when you change the value of the resistance, basically you change the voltage that goes into this analog pin. And the value of that voltage is basically it's digitized or normalized, or has the range between 0 and 1023. Basically 1023 means 5 volts and 0 means 0 voltage, basically. So that 5 volts is basically normalized to this range. Now the code for it, in the setup function, we have the command serial.begin 9600. That's basically an object that allows the program to write on the screen, right? So it's a serial port that's used to display values on the screen. So we set that up, and then inside the loop we are going to declare a variable, sensor value. It's an integer, and then what we store in there, we are going to read analog read is the function, analog read A0. So we're going to read the value on this analog pin A0 and then store it in sensor value. And then what we're going to do next is actually use that that object, serial object, and then print the value of the sensor value. And that value should be something between 0 and 1023. And then a delay of 1 millisecond in there as well. And I'm going to demonstrate this program to you shortly. Here is our Arduino sketch. The program for the analog pin is right here, exactly the same program that we described. Now to compile this program, I'll go to Sketch, and by the way, there is the setup function, same code is there, and there is the loop, same code is written in there as well. I'll go to Sketch, Verify and Compile. There's a compiler for this system. If I change something, for example, if I make this A right here, if I make it an uppercase A, it's not going to recognize it and it won't compile, give me some error, right? So it's a compiler, checks on syntax, and then once it compiles, let me one more time compile it correctly, then I can upload it. This is how you upload it. You go to Sketch, Upload, is uploaded, and now it is uploaded onto the board that I have attached to the computer. Now this serial print line that you see here, in order to see it, you will go to Tools and then Serial Monitor, and right here you can see the value of the voltage on the analog pin. On my circuit, on the circuit that I have, I'm going to change this. This is 0. Now I'm going to rotate it to the right. It goes up and all the way up. It goes all the way up to kind of 1023. There it is. That's the maximum. So you can change it. I'm basically turning that shaft basically on the potentiometer, and this is the voltage that goes into the pin A0. All right. Now in this example, I'm going to basically connect a potentiometer to analog pin A0 and then use this A0 voltage as basically voltage for pin 2, and use pin 2 as output pin to power the LED here. The diagram that I have here indicates pin 2 is attached to LED. In fact, it should be a PWM pin. It should be pin 3 here, that's the designation. This small dash that you see here, that designates that this is a pulse width modulation pin, and we have to use a pulse width modulation pin for this particular purpose. So I have this potentiometer. The left and right pins are connected to power and the ground. So there's 5 volts comes to this pin right here. As I said, all these kind of pins vertically, they're all connected. They're all the same. So all these points that you see here, they all represent 5 volts. And then the ground is coming to this pin. That means that all these pins represent ground. So the right pin of potentiometer is powered, the left one is ground, and then the middle pin is connected to A0, an input pin. And by rotating the shaft, I can change the voltage of the value between 0 and 1023, basically going into A0. Now what I'm going to do, and that's the input by the way, all the analog pins, they are used as input, so it is inputting the voltage in. Now digital pins can be used for input or output. Now I'm going to use digital pin, in fact let me just keep saying 3 in this case, in Arduino Uno. It has to be one of these PWM pins. I have it mistakenly 2 here. I'm going to set that pin to an output pin, so basically the current flows out of it. I have the serial port also set up to print the value of it. Before that, let me also describe these variables. Pin 2, it's just pin 2. Pin A0 represents A0, should be an A here, A0. And then the value, the integer value, is set initially to 0. In setup, I have the pin mode for pin 2 to output, set the serial for print purposes, and then inside the loop, this is the important part basically, the value that I've declared earlier, I'm going to assign to analog read pin A0. So the value of this pin A0, whatever it is, it's going to be read into the value. And that value is between 0 and 1023. Now, the pulse width modulation pins here, they have a range between 0 and 255. So we have to map that the range 10 to 1023 to the range 0 to 255. And there's a function already provided to us, and that's called the function map. So I'm going to map the value of A0, map that value to a range between 0 and 255, and store it back into value. And then, that's also important, analog write that value, which is between 0 and 255, into pin 2. So now pin 2 is powered with that value between 0 and 255. 0 means 0 voltage, and 255 means the maximum voltage of 5. So anything in between will range between that voltage. And then I can also write that value to the screen just so that I know what it is. So basically what this circuit does, I can basically rotate this knob, this potentiometer, and by rotating it, I change the resistance here, thereby I change the voltage here, the analog voltage here, and that voltage is mapped to this output pin, basically, pin 2, and that pin basically powers up the LED here. That's the idea. So I can basically dim the LED based on the amount of voltage that I supply. Now in terms of programming, this is the code that you see in here, and we can go to Sketch, verify it, compile it basically, it compiles, and then we're going to upload it. It uploads, I can see it on my circuit here that things are working, and then here is the serial monitor, and the value is mapped between 0 and 255. So as I turn it, the LED gets higher and higher intensity, all the way up to maximum of 255. You don't want to go all the way up, you may burn the LED. There it is, that's 255 max. And then I can bring it back down. This is the intensity. 0, so we can play around with that. Unfortunately, I wasn't able to get a video of this, but soon I'll have a video set up so that you can actually see the circuit. So practice with these couple of examples and see how you do.